Chapter 4, Number 38. The hang time of a punt is measured to be 4.50 seconds. If the ball was kicked at an angle 63 degrees above the horizontal and was caught at the same level from which it was kicked, what was its initial speed? This is an interesting one. So if we go here and we say, let's draw our usual kind of picture, and we are going to kick the ball. Oops. Well, that's fine. We're going to kick the ball at some initial velocity with some initial angle, and then the ball is going to track out and land in my, again, not particularly great parabola. And we're told that this happens at a total time, which is, I'm going to call it time of flight, and it's 4.50 seconds. And we also know, I guess, that theta is 63 degrees. And we're interested in what is V0. That's what we're looking for. So there's lots of ways to tackle this problem. I think one of the easiest and most interesting ways to do it is by using the symmetry of the parabola, the symmetry of projectile motion. And that tells me that at the highest point, where Vy happens to be 0, that will occur, and I'm going to call it T sub m, or midway, is going to be half of that number, which is 2.25 seconds. So at 2.25 seconds, the vertical velocity has to be 0. So that allows me to go back and sort of say, okay, but at all times, the velocity in the vertical direction is the initial velocity plus the acceleration in the vertical direction times the time. So plugging in this time and the fact that we know that ay is minus g, I guess technically, we end up with that 0 is v0y minus g times the midpoint time, and therefore v0y is g times t times the midpoint, or 9.18 meters per second square times 2.25 seconds, or 22.07 meters per second. I'm keeping some extra digits because this is not our final answer, so I'm going to keep some extra accuracy and then get rid of it at the end. All right. Sadly, that's not actually what they asked us about, so we'll need to say maybe go off to the side here. Let's give ourselves a little bit of room on the side. And move over a bit, and then say what we really have is a triangle with speed v0 and angle theta, which was 63.0 degrees, and now we know it has v0y and v0x, but we know that v0y is 22.07 meters per second. So doing a little bit of trig, we say, well, I have over here, that's the opposite side. And, fine. Over here, sorry, wrong guy. Over here, that's the hypotenuse. And we know that the ratio of the opposite hypotenuse is the sine of the angle. But based on the numbers that we have, we know that the opposite sine happens to be 22.07 meters per second, and that the hypotenuse is the thing I'm looking for. And over here I have sine of the 63.0 degrees. So I just have to kind of solve this over, which is a little weird, right? I have sine theta equals 22.07 over v0. So I have to cross multiply by v0s, and then I need to divide by sine of theta. And after all that crisscross work goes on and the dust settles, we end up with that V0 will be 22.07 meters per second divided by the sine of 63.0 degrees. And sine of anything is dimensionless, so I have a thing that's in units of velocity, which gives me some faith that maybe I did the right thing. If I go into the calculator and type it out, I get that the initial velocity is 24.8 meters per second.